Pretty cool, huh? All right, so we're going to go back over how to use Pascal's pretty quickly. So here we have x minus 4 expanded to the fourth power. So that means x minus 4 times x minus 4 times x minus 4 times x minus 4. So yesterday we went over all the steps that would be necessary to turn this into its answer. That bell is for the beginning of class. Good job getting here on time. Actually early, so I can start. So, how would this compare to Pascal's? Now, does anybody understand how we built the triangle yesterday? Yes. So you could build the triangle. All right. So what we want is that the fourth power, so that's going to be the one where we have the 4 in it. This is to the 0, to the first, to the second, to the third, to the fourth. So that's our fourth power. So the first thing we do is we go in, we put those coefficients in. So we put in the 1. We put in the 4. We put in the 6. We put in the 4. And we put in the 1. Because we know those coefficients from Pascal's. And then what we have to do is start by taking that first term in our binomial and raising it to the fourth power. And the second term to the 0 power, which I don't really need to write, because anything to the 0 power is 1. Then the first term to the third, the second to the first to the second to the second, the first to the first, the second to the third, and then finally the second one to the fourth. We could write the first one to the 0, but that's just 1. Now, it was just fine when it looked like this, because x to the fourth is just x to the fourth. But on your homework, we had one that had a coefficient with it. So let's say I took the same type problem, but I did it to the fourth, so I'm doing the same coefficients. I still have the 1. I still have the 4. I still have the 6. I still have the 4. I still have the 1. But this time, when I think about it, this whole term is raised to the fourth power. On your homework, did you raise the whole term to that power? Right. So that would make it the 16th. This whole term is raised to the third power. This whole term is squared. So we're good on that? All right. Well, let's go ahead and check your homework then. We'll start with these, and I'll answer questions about these first. Now, it is all worked out here for you. You see, this is the third one. So if we look at Pascal's, we know our coefficients are 1, 3, 3, 1. Look, 1, 3, 3, 1. This is the fourth power, so it's going to be that next row. 1, 4, 6, 4, 1. 1, 4, 6, 4, 1. And then what we have to do is make sure we're raising the whole term to that power. All right, so take a look at those. I'm going to come by and check your homework while you're checking. Oh, you went down and didn't do it, didn't we?
Which one?
Number 20.
Oh, I didn't?
You were with me too?
Yes, ma'am.
No, win here. Good job.
Explain to me how I got number 20 right, but not 12 and 14.
Miss Willoughby, Pascal's triangle is just for coefficients, right? Or is it also for the exponents?
It's for expanding binomials.
I wrote this one.
You work from
You just put 1, 4, 6, 4, and 4 for the
The 1, 4, 6,
work down.
those are your,
And the right turn goes up from 0 to
well, it may not be the complete one, but it is.
Okay,
Yeah,
well,
exactly.
first term.
Okay. So, if you have
The next term.
It would like say
the first part of that.
A
Putting 3 in the second part of 1. That adds up to 4. Then be 2 to 2. Then 1 to 3. Then be 0.
so you'd have the 1 A.
Okay. Okay.
And then it's
Like,
squared.
yep, I remember that now.
Confused to where you get the square. Okay, for, waiting for multiply close, that's what I'm calling.
I don't see the 4 to 0 on the first one though.
No.
Because you don't have to
If
write.
you bring me good chips tomorrow.
You don't have to write something to 0th power. It's just 1.
Well, you bring me something I said tomorrow.
Oh. Is that the very first one? 1, 4, 6, 4.
Do you have any of the spicy pieces or the pretzels or the beef and stuff?
So that's what I was getting there.
So tomorrow. Okay. So I'm going to my notes. Okay.
Because
Okay.
what's taking us to just go on.
So
Like this one to the third.
6.
When you're writing it.
Alright, so is it Pascal triangle? These numbers go outside. the
Okay,
bracket.
let's do one more together
Okay,
then.
and
Oh, I love that.
then
Thank
raise
you.
it. This
Okay,
first one.
so let's
6
do.
and count down.
If I just keep stacking.
So, and then plus 6
I'll make up one.
A to the 5th first, and then the G's count up.
Okay, so let's say we have like 3x minus 2y.
Your last one is only going to be B to the 6th.
We can go up to maybe the 5th. What power do y'all want? 4?
4.
4? Okay, 4. Okay, so let's do the triangle. 1, 1,
Well, yeah, but
1, 2,
the
1,
times doesn't matter.
1, 3, 3, 1, 1, 4, 6, 4, 1.
Then plus
Okay, so this is what I'm going to start with. The 1, the 4, the 6, the 4, and the 1. Does everyone understand that part? Okay. Now, what we have here are 2 terms. First term, second term. Do you see that? So what we do is we start at this end, and we take the first term, and we raise that whole term to the highest power, which is 4. And then that would mean the second term would go to the 0. Do I need to write to the 0 power?
No.
Nope. So I'd say plus, I'm done with that one. Now, I take the first term
Wouldn't it still go to, it'd just be 1 though, right?
to
The
the,
0th power should be 1.
yeah,
Yeah, but you're
and
just
1 times
multiplying by
anything is
itself.
just,
Oh,
yeah.
okay.
So you want the
So this would be to the 3rd. And then the negative 2y would be to the 1st. Plus the first one squared. The second one squared. Plus the first one goes down 1. The second one goes up 1. Plus, well, when the first one goes down 1, it goes away, right? So the second one goes up to the 4th. Okay? And then we simplify what we have. This is all a product of multiplying everything. So it's 1 times 3 to the 4th times x to the 4th. Well, 3 to the 4th is 81. So it's 81x to the 4th. Okay, the next one. 3 to the 3rd is 27. So 27 times negative 2 times 4 is negative 216.
Miss Willoughby, on the homework, the problem is kind of like the one you're doing. You had positive 216x for the first one.
Probably on the homework it was positive.
Because it's the,
This one right here?
yeah,
Yeah, it's a plus there.
I did the
And
wrong
I'm
one.
doing a problem that has minuses now. Okay, so for the next one, my coefficient's going to be 6 times 3 squared, which is 9, times 2 squared, which is 4, so that gives us positive 216. And when I square the negative 2, it's positive. And this is negative 8 times, so it's going to be a negative 96. And then negative 2 to the 4th is a positive 16 to the 4th. Did that help?
Yeah.
Alright. So that's how we expand binomials. Now if you would like to pick another one and try it tonight, I have the answers for all of them. You can check them. Okay? Alright, let's check the rest of your homework. See if you have any questions about those. If you do, please note that every single step of work is shown on the overhead. See if you can find where you went awry without me having to show you.
Please, do we, I forgot to say. We could put it in exact order.
Okay, I definitely want it in the correct order if there's only one variable. So on 1 through 6, it should have been fairly easy to tell. Now on this one's okay. This order, it's alphabetical. You see how it goes from X up to Y. So it did the highest degree for X, and then went alphabetical to your Y up to the highest degree for Y. So that happened on 7 and 8. It wouldn't be wrong if you put it in different order, but it's pleasing in the order that it's in. X goes down, Y goes up. Alright, any other questions? Okay, so we learned how to classify, then we added and subtracted and multiplied by monomial, and then we just multiplied polynomials, and we expanded polynomials. So we did a binomial to a power. Today, we're going to do what? What's left? What operation is left? Division. Today, we're going to do division. Was that yay? Did I hear a yay? Uh-oh. That's what I was afraid of. Huh. My first period. Okay, so if you guys will get out a sheet of paper while I erase all the answers really quickly. And we'll come up with these same answers in just a second. polynomial x plus 2. And it will be dividing into okay, if I was missing one of the powers, you could put in a 0. So let's say there was no 2x. Right here we could put 0x in. Or there was no x cubed. We could put 0x cubed to hold its place. Some of you might find that beneficial if we're missing. And this is pretty simple. What we're going to do is we're going to take the first term in our dividend and determine how many times the first term of our divisor will go into it. So if we looked at this, just this, what would that simplify to?
To the third.
2x to the third, because one of these would cancel with one of those and leave 3, right? So when I take 2x to the fourth and I divide it by x, it leaves me with 2x to the third. Oh yeah, you're gonna have that worked on. It's gonna do what mine did. It's already starting to grow back funny.
It's kind of scabbing up.
No, it's growing. We're getting extra skin there. You're gonna have a really good looking skin flap like that.
Not bad.
Oh, it's gross.
Oh, it's bad. It's gross.
It grows out instead of covering. When it's on your knuckle like that.
Oh, is it like this? Like that? Kind of like that? I mean, that one like kind of came at a side.
Okay, you can
That's
see.
how it's weak.
See right here? See that little? I've had it flapped up like that, and I had extra skin flap like that, and they had to go back and sew. So, see, mine happens in the same spot. Good luck.
That was lots of therapy, I guess. Or squeeze it together or something. Or
Alright.
get a sewing kit and sew it yourself.
I wouldn't recommend that.
Probably
Okay, so are we all together now that I've shared my gross story? So now we take this and we multiply this just like we used to with long division of just plain old numbers. You would take the quotient part and multiply it right here to see what goes here. So 2x to the third times x. What does that give us? 2x to the fourth. Good. That's what we wanted to happen. And then 2x to the third times 2. What does that give us? 4x to the third.
Just
Okay, hold on. Okay, when we did it this way, wouldn't we look at this number? Okay, let's change this. Wouldn't we say this number goes into this number how many times?
One.
And then we did 1 times 3 is 3, and then we would subtract and bring down, right? Then we say 3 goes into 10 how many times? 3, and 3 times 3 is 9, and then we subtract and bring down. Same thing. Same thing. We just have polynomials. Okay, so now I multiplied. So what was the next step here? What did I do right here? I subtracted, so I'm going to subtract. When I subtract, it's going to change these signs. And what happens?
0.
It all canceled, didn't it? I got 0. So I'm going to bring down. Just like I brought down over here. I bring down over here. Okay, now x goes into negative 3x squared. Let's look at that. Negative 3x squared divided by x. What does that leave us with? Negative 3x. So then I'm going to multiply. And when I multiply, I get negative 3x squared. Change colors. Minus 6x. Okay.
Where did you get 6x?
You multiply by the sheet.
You
Oh,
multiplied
that's
by
about
the
two.
2.
Okay. Now, do you see that nothing's lining up above 6x? Well, what can I do with this negative 2x?
Bring it down.
Bring it down 2. There we go. Now it lines up nicely, doesn't it? Okay, so now we're going to subtract, and when I subtract, what does it do? Changes the signs. So I get 4x left. And then I bring it down.
We get the
And then x goes into 4x. How many times? 4. And then I'll change the signs. And what?
0.
0. That means there's no remainder. My
Yeah,
remainder
yeah.
is 0. Yes, my next one will have a remainder.
You're right.
So, when this is divided by that, my quotient is this. Now I can check my work by multiplying these two and see if I got that back. Remember when you first learned division, they made you check and make sure you did every problem right? So you could multiply the quotient times the divisor and it should give you the dividend. You could just look at it. I wouldn't actually do it. Okay, so here's a different one. Now, do you see there's an x missing? It goes cube, square, oop, no plain old x. So if you wanted, you could put in a 0x. And now it lines up nicely. Okay, I'll write that down, and then we'll work it.
What happens if you don't put in a 0x?
Some people are just fine, and they notice it. People that don't pay very good attention to detail will add things that won't add together.
Okay.
Okay, so 2x cubed divided by x. What does that give us? 2x squared. Okay, so you guys go ahead and give me that first line. Good. Okay, now we're going to change our signs. So we're going to change. And that gives us 10x squared. And we bring it down. Plus 0x. Okay. X divides into 10x squared. What does that leave me? 10x. Okay, put the 10x up and multiply through. get to a point that what's left is of lesser degree than what we're dividing by, that's my remainder. This is now my remainder. And the way we're going to write our remainder is we'll say plus the remainder over the divisor. Oops, that divisor was x minus 3, I'm sorry.
Miss Willoughby, wouldn't the 90 be negative because we're multiplying? Oh, it's how do you get a positive 30?
Because you have to subtract. See how every time I subtracted, which changed the signs of everything?
I know, I did that, but I'm just messed up. I got a negative 30. I got a negative 30 on the top, and then I got a negative 90 down here.
Okay, questions? Alright, now, this one. This problem is really this. 3x to the 4th minus 2x plus 5 divided by x squared minus 2x plus 3. So we're missing the cube and the square here. So if it keeps you from forgetting about it, you might want to put the placeholder in. Put the 0x cubed and the 0x squared. Now you do not have to. If you pay really good attention to detail and you're not going to combine terms that are not alike, you don't need to put it in there. When I work the problems, I don't usually write the 0x cubed and the 0x squared in there. I would just leave a big space. But you may want it. Okay, so let's look at the first one. What does that give me?
3x squared.
3x squared. So that is 3x to the 4th minus 6x to the 3rd plus 9x squared. Okay, and then we subtract. So what happens when we subtract? Changes all the signs. Change, change, change. So that leaves me 6x to the 3rd minus 9x squared. And since my divisor is a trinomial, I want to bring one down. So it looks like I'm dividing into a trinomial. All right. X squared goes into 6x cubed. How many times? 6x. Then change the signs. Good. Okay, so that leaves me with 3x squared minus 20x. So my divisor is a trinomial. I'll bring it down. Okay, so what goes here? 3. So I get 3x squared minus 6x plus 9. Change, change, change. Okay, will an x squared go into an x? No. What's remaining is a lesser degree than my divisor, so this has to be the remainder. So it's, you could either write plus negative 14x minus 4 over this, or you could write minus and make those plus. You can do it either way. Because that's the same thing, right? Minus this is the same thing as plus this. No? Are you telling me? Okay, good. Phew. Alright, so that is log division. Now, almost every time I show you something that seems long, there's got to be a shortcut. There is a shortcut. It's called synthetic division. But synthetic division only works in specific cases. It only works if your divisor is a binomial. It only works if it is a linear binomial. And we're only going to use it if it's a linear binomial with a coefficient of 1. So in very specific cases will we use it. But it's a nice shortcut. I like it. Okay, so now we're going to do synthetic division. And synthetic division we're going to use when your divisor is a linear binomial with a leading coefficient of 1.
It is very specific.
It is very specific. Okay, so this is very nice. The first step is we look at our divisor and we always do the opposite. About it is, what could I plug in here for x that would make this 0? So what would that be? Negative 7. And then we place that number over here, like that. I call it on the table. Okay, then the second thing we're going to do is list our coefficients in order of degree. Now, you must put in a 0 this time if anything's missing. Or our shortcut won't work. Okay, so I've got cube, square, first power, constant. Is anything missing? No, so I'm not going to need any zeros. What is the coefficient of the first term? 1. Coefficient of the second? 7. Next. Last. Constant is 35. So I guess this would say list coefficients and constant. Okay, every time we will bring down the first term. Need some water? take what's on the table, multiply it times that term. Negative 7 times 1 is negative 7. And then we're going to add. 7 plus negative 7 is 0. Then we're going to multiply. Negative 7 times 0 is 0. Then we're going to add. 5 plus 0 is 5. And then we're going to multiply. 7 times 5 is, negative 7 times 5 is negative 35. Then we're going to add 0. Okay. The last number is always the remainder. So this one has no remainder. And then we work our way backwards. This is our constant, this is our linear term, this is our quadratic term. So this is just our number. This would be our x, so we have 0x. This is our x squared. So it looks like this, x squared plus 5. And that's our quotient. Now if I'm like x squared plus 5 times x plus 7, do you see you get this? Because x times x squared is the x cubed. 7 times x squared is the 7x squared. X times the 5 is 5x. 7 times 5 is 35. Yeah, so we did it right, didn't we? Yes.
I don't get how you got the like negative 7 and 0 and negative 35.
Okay, let's do another one then. Okay, so let's say we had 3x cubed minus x plus 7. And we wanted to find the quotient when we divide by x plus 3. So I'm dividing by a linear binomial with a leading coefficient of 1. I can do synthetic. So every time on the table I do what can I plug in for x that would make this 0? What is the opposite of that constant? Negative 3. Then every time I list my coefficients. Okay, so this is third power, biggest one, 3, goes here. Then I would do squared. Is there a squared term? So what has to go next? 0. Then what's my coefficient for the linear term? Negative 1. And then 7. Every time I bring the first one down. And then I take what's on the table, multiply it times that, which is negative 9, and then I add. What is 0 plus negative 9? Negative 9. Then I multiply. Negative 3 times negative 9 is 27. Then I add 26. Then I multiply. Then I add. Okay, every time this last number is what? The remainder. So my remainder is going to be a negative 71 over my divisor is x plus 3. So this is my constant, 26. This is my x, negative 9x. This is my squared term, 3x squared. Okay? And that's how synthetic works. Now, you may use synthetic whenever your divisor is a linear binomial with a leading coefficient of 1. Okay? It's much quicker. I will, when I assign the calculators, I will give that back to you. You'll fill that in. Thank you. Anybody else have a calculator form for me? I will find your actual calculator numbers one at a time.
So which one was
also told me that was not possible, that you had to have errors in math, and that my worksheet had to be wrong.
That's what they told me yesterday.
It was just something else's problem, and I always do good things. So that one happened to be Josh. They're like, as long as Joshua is Joshua, he doesn't make mistakes, so there's something wrong with your problem.
Did you get a 2? That's why the zeros there. You're getting a little bit better than
She's dying.